And welcome once again. I am the database guy. We are in our second presentation, or second video rather, of presentation 9 in our VBA basic section here. So when we look here, we kind of finish scope, and I always say tentatively with anything that we do, because we can always go back to it. We usually do. But as always, please like and subscribe. This is coming free to you. And as we continue our journey into our course within a course, which is this Visual Basic, we're going to learn about statements and the if-then statement and the select case. These are the first two statements that anybody ever learns about. And you'll find them in various platforms of programming. You'll find them in C# or C++, or you'll find them even in a way in Python. And these are what we call logical statements. But you must be careful about how they're evaluated, because when you write them, if you don't write them in a certain way, you're going to not evaluate exactly what you want. So, and that's another portion of scope, right? The scope of the statement, going back to, that's why I say anything we talk about is sort of tentative here. But what is the scope of the statement? What does it cover? All right. Let's take a look at the if-then statement. So it starts this way, this syntax, and syntax is how things have to be written, otherwise you'll get an error. If, and there's a first condition, and that can be one or multiple conditions. It could be if x equals 5 and y equals 2, then do something. But we got to be careful, because when we want to outline the logic on something, and we're going to do some examples of this in the database, we've got to start with the general logic, the basic logic of one condition. So let's say if x equals 5, then do something, right? That's actually should be here. And I didn't put that in there, so let's do that. Do something, which is going to be here. Else if second condition, do something else. Actually, let me put that color in there, and didn't finish the statement. Boy. Let's go with the blue. Do something else. And else remaining condition, right, we're going to do something else here, all right? Whatever you want to, however you want to put this, doesn't really matter. Else. And this we're going to say is different than, of course, the first do something else. So you would have in here, so let's say if x equals 5, then y equals 6. Or if x equals, else if x equals 6, y equals 7. Else y equals 10. All right. Now these are general, in the general sense. So we're going to write some code here. We're going to do this in a function. Call this EF for else if. I didn't spell function right. That's why I'm not seeing it come up. There we go. So we're going to say dim x as integer, comma y as integer. And we're going to start our if then. Well, let us set so let us say we'll set them equal to 0 to begin with. And actually should be x equals 0, y equals 0. Okay. And if x equals 5, then, whoops, we didn't spell it right, then y equals 6. else if x equals 6, then we got to put the then in, then y. Let me just see if I had that in my statement over there. I should have. Got to put the then in there. Yeah, we need to have a then in there to be the correct syntax, right? And then y equals 7. And then, of course, else y equals 8. And if. And we'll check our syntax and make sure we're good. And we are, and well, we have something in here that is my goof. Sorry about that. So let's just must have had some kind of characters I put in that have no meaning whatsoever. All right, let's expand this. Um, so we need to have input data in, and there's an input statement, I think. Let me just see. Well, actually, we can do it in various ways. We'll use this, and we won't even set x equal to 0 or y equal to 0. What we'll do is we'll go to our form test, and let's open up our form test. Here's how we're going to do this. I need to input data in. So what I'm going to do here is insert um, text box. Good. And this text box here, we're going to call txt input. We're going to input our data in. We're going to come to this control here, P1, and we're going to change our procedure in there. Okay. We're going to save this and debug it. And, oh, we don't have anything in there. It got rid of our procedure, so let's put it back in. Yeah, there's nothing there to get rid of it. So me.txt, well, actually, we're going to create, all right, we're going to create, let's go back to our module. You know what we're going to do? We're going to create this as a public or global variable. So we can use that in our function. We have to do this as global, and I think we can do this as global or public. Doesn't matter. Let's see, I think it might error out. All right, no, we can't. We can do it both that way as well. So we're declaring public variables, and then we have to run the function when we click it. So coming back to our, and I'll go over the code again so you can see it. And we didn't put anything in it, so it disappeared again. Let's go back to our on click. All right, so x equals me dot txt input, and then we're going to run that function. So let's ef and then, by the way, we're going to debug at the bottom, print x comma y. We want to see the values we're going to print. So when we look at this code, let's look at the first one on the test. We're saying set the value of x, which is a public variable here. Set that value equal to whatever I have in my input. Now I have to have a value there. If I have nothing, it's going to set it to nothing too. So we're going to run, we could run another if then to check the value of me text input. So here's your first variable set equal to a control. Once we do that, we have that value. Then we're going to run EF. And EF here says, okay, if x is 5, then make y 6. If x is 6, else if x is 6, make y 7, else make y 8. Right? I am not going to get into the checking of this just yet. All right, so let's go here. We're going to save this, and we're going to see what happens. Go to form view. We're going to have 5 here, and press that and see what it does. And so we look here, as you can see, and since x is 5, y 6, right? Okay. Now we're going to change x to 6. Okay. I'm going to press that button again. 6 and 7, exactly as the logic says. Now the last part of it, I'm going to type in 25 and hit enter. I'm going to type in 0 and hit enter. And I'm going to type in -7 and hit enter. And as you can see, it doesn't matter what value x is. If it's not 5 or 6, it's going to make it 8. So you can see how the logic here is weak, right? It's weak in a way such that that else statement cannot differentiate anything else. It's a catch-all. So if x is any other value, so I typed it in here, and I comment, so if x equals 5, then y equals 6. That's the evaluation of that first piece of code. Else, if x equals 6, then y equals 7. Whoops, I'm sorry. Didn't want to do this. There we go. I'm commenting here. And then the last one, if x is any other value, y equals 8. You can see sort of the weakness of this kind of commentary about how it works. All right. In an if-then statement, right? This is one condition for an x or whatever the value is. I could set in multiple conditions, but my logic would have to be correct. It would have to work correctly for that one. All right. I'm going to copy this, and I'm going to make this EF2. All right, and we're going to write some different logic for EF2. We're going to go here, copy this, paste it underneath it. So we're going to name this one text input 1, and we're going to name the other one text input 2. I'm going to show you some logic so you can understand what happens to. Save it. Okay. Go back to our function here globally. Let's see. Yeah, and we're going to put z as integer. All right. So in this logic here, right, we're going to say and y equals 6, then z equals y plus, I'm sorry, x plus y. No, y, we'll call it, well, x plus y. X plus y. All right, so, and take out my comment here. Else if x equals 5, um, and y, or y equals 6. All right, or y equals 6, which is a different logical way to look at this. Then z equals x plus y. We're going to do the same kind of thing. Else z equals 0. But I'm sorry, 0. Wrong. All right, we're going to debug print x comma y comma z. Well, now this is interesting logic here. We're using an AND operator and an OR operator. The AND operator means both conditions must hold. The OR means either condition can hold. So I'm going to debug this one, make sure we don't have any issues with it. And we do have one, obviously here, because we've changed it. X equals text input 1. Y equals me dot txt input 2. And we're going to run EF2. Compile that. Save it. Good. Now here's the logic on this one. So we put a 5 in here and a 6 in here. We have them now the way that they should be. Obviously, this is X, this is Y, and we can put the labels here and probably should have had them there. So I'm not going to worry about it now, but we press this here, and now we're going to go see on our, so 5, 6, and 11. That's good, right? Now, all right, if we press it here, we're going to get 15 because we're seeing the 5 as X. And we only need to see that one condition. That's the OR. So if we go back to that, let's go to our function. We only need to see the one condition, the 5. Once we see the 5, we don't need to worry about what y is. An OR condition means neither one has to be met. So the only condition you get 11 for, or should get 11 for, is if x is 5 and y is 6. You'll never get 11 for any other condition. Well, you could. I mean, well, no, you wouldn't. I'm sorry, you wouldn't, because you'd have to have 5 and 6. So here we got 5 and 10. We see the 5 on the OR. It's evaluating this one here and saying, okay, add them together again. 5 and 10 is 15, whatever. It doesn't care what y is. As long as x is 5, it's going to add whatever x is to y. Let's reverse that logic. 12 and 6. Up. Okay. That's 5, I'm sorry. We press it here. Take a look at our output. So here, 12, 6, and 18. Right? So it sees the 6 for y, doesn't care what x is. So when it evaluates, it says, well, x is not equal to 5. Okay. Well, actually it takes the first statement. X is not 5, and y is not 6 together. So it goes to the second statement. X is not 5, but y is 6. So x plus y. Get the 18. Let's just clear this out of here. Right? And the third condition, let's see what happens. 0. All right? So neither x nor y, x is not 5, and y is not 6, and x is not 5 or y is not 6. So it'll go to 0. So the logic here is on the OR operator, I need to meet one condition. On the AND operator, I need to meet all conditions. And you need to be careful with the scope of this, because again, with that else condition, it will trap everything for when x is not 5 and y is not 6. Now, let us look into some different logic and some different operators. So we did equals and we did, right? So here we're going to say if x equals 5 and y equals 6, right? And else if x equals 5 or y equals 6, then that one, else x does not equal, and that's a does not equal 5, and y does not equal 6. That's another operator we're going to learn. Okay, so, oh, I'm sorry. I've got to put the comment here. It's thinking it's a statement. There we go. So now we can change the statement here. If I said if x does not equal 5 and y equals 6, that's the same statement here. Well, it isn't the same statement. So let's see what happens if I add another statement in here. We're going to do another statement here, another else if x does not equal 5, right? Or I'm going to throw in one more, and y does not equal 6. So let's see how this differs from the first statement. So if else if x equals 5 or y equals 6, it could be either one. But in the second statement, if x does not equal 5, what that means is it's anything other than 5 or y equals 6. I'm going to evaluate that as, and I'm going to put this one as x times y. And here I'm going to put this one minus. I may get a negative number. I don't know. So difference between your first and second statements are as follows. If either one of them is 5 or 6, it'll evaluate that statement. On the second statement, if x does not equal 5 and y equals 6, all right, you will then get that evaluation, the times evaluation. And if x equals 5 and y does not equal 6, you'll get the subtraction. And then the final one, if neither one is equal to 5 or 6, x does not equal 5 and y does not equal 6, you'll get the final evaluation. Let's test it out. So let's start from the beginning, make sure it still works. Oh, and I want to debug and make sure I get everything right here. And I do, and everything's fine syntactically. So let's take our first one here. We should get 11, and we indeed do. Now, let us now. So now, really, the first else if means, and let's see what happens. So I don't think we're going to need that because if x equals 5 and y does not equal 6, then we should get something different. Let's see what happens. So let's try 5 and 7. Let's evaluate it and let's see what we get. So 5 and 7, 12. So what's happening here is it's adding them. So in this particular one, it says, okay, x equals 5, but y does not equal, or y equals 6. It's taking the very first one in order. Notice it didn't take the last one, x equals 5 and y does not equal 6. Isn't that interesting? It didn't take the last one because it's evaluating these statements in order. And that's the scope you need to understand. Okay, well, let's see what happens now if we reverse this. 7 and 6, and we run it. And we get 13. So what is it doing? It's evaluating this statement right here. It's not even getting to the other two, okay? Why? Because when if-thens evaluate things in order, so those last two statements are useless. Truth be known that x does not equal 5, or rather, I'm sorry, this condition here, x equals 5 and y did not equal 6, should evaluate to this. What I'm going to do here is I'm going to take this and I'm going to select it. Up here, you will see uncomment or comment. We're going to comment the block so it won't run. Okay, now we're going to run the same conditions for the first two here, 5 and 7, and see what happens. And it's giving me 0. Okay. Let's see. So oh, I forgot my else. I don't have the else. Oh, I know why. Over here, it's evaluating the statement here, but I don't have the else. And we need that. So let me put that here and reevaluate this. It's giving me, it's actually setting it to 0 there. So, I lost the else statement. It must have been up here, and I commented it out with this, or got rid of it, deleted it inadvertently. So it's set z equal to x minus y, and then z equal to 0. That's why I got to 0. So let's evaluate it again correctly. Let's go back in here, and surely enough, we have the subtraction. So it looked at it and it said, okay, x equals 5, but y does not equal 6. So subtract the two. Now, let's reverse this and do our 7 and our 6 and go with it. And here we got the multiplication, right? So if x does not equal 5, but y equals 6, multiply them. So, what you learned here, what we showed is that one of the weaknesses of if-then is it evaluates statements in order. In other words, if it comes to a condition that it first meets in the order of evaluation, it evaluates that first and it stops. So if I place this back in and I take it away, and we're going to just select it again here and uncomment it, and I run it one more time, you're going to find that it's now adding them because it's the first statement it encounters. This is a weakness, and it's known to be there, but it's not something that's terrible. What you have to understand when you're working with Visual Basic, with an if-then set of statements, is that your logic has to be clear because you're going to evaluate each statement as you go. Once it meets 1, it's going to stop dead. And so what is the difference really between the last two else ifs, okay, and the very first else if? And that is that you have a catch-all for x not equaling 5. All right, the first one we'll look at X could be 5 or Y could be 6. And it's really the same thing. So in other words, I split up this statement, this OR statement, into two statements. All right. And said, okay, Y can be 6 and or X cannot equal 5. All right. So either condition will be met. And as long as either condition is met, it will give me what I need. If I had an AND in there instead of an OR, I would have to meet both conditions. So that one, and let's see what happens on the AND rather than an OR. It probably won't be too much different. Well, let's see what happens when we run, just as we have here, 7 and 6. And we get to 42. So, question, why does OR and AND work both the same way? Well, AND meets because X is 7 and Y is 6. Both of them meet. Now, the OR is weaker because it only needs to meet one condition. So X doesn't equal 5, bang, it meets the condition. It's the first thing evaluated. All right. If I had X equal to 5, and let's flip that around here. Now I'm going to get the AND. I'm going to get, right, I'm going to get the AND here. But if I had the OR, it would have evaluated it immediately for 5 only. Didn't care what X is. It found X equal to 5, right? And then it would look here, well, Y is not 6, so I'm going to go down to my next condition. Well, this doesn't meet because we know it's 5. This one meets here, right? And the OR would also meet as well. So AND and OR, the difference between them both is I need to meet only one condition here. And once I have the OR there, I don't need to worry about the other condition. So placing OR there, whoops, sorry. Let's do that again. We'll place OR there and see what happens. I should get the same number. It doesn't really matter. It will evaluate it exactly the same way because it says, okay, 5, X is 5. And I don't care what Y is. It's something other than 6. Well, I do care, and it's something other than 6. All right. If X equals 5 or Y equals 6 on the very first one, let's see what would happen. What do you think would happen? Well, I've already met X equals 5, so I should add them. I don't care about anything else. All right. And let's see. And I add them, of course, because I met the first condition in order. All right. I don't care about any other condition that could be met. So using and or operators are very interesting in the types of operations that you can have. You got to be careful. If I set two conditions with an and I've got to meet both conditions. If I set it with an or, I need to meet one condition. All right. And if we look at this again, so let's write our statements here. Let's see here. Let's take this out. I don't want to have this in here. Else if, so we're going to say here, else if X does not equal 5 and Y equals 6. So any value other than 5 for X and Y must be 6. Here, else X equals 5 or y does not equal 6. So if x doesn't equal 5, right, we can look at this one here, and then it'll say, well, what does y equal? If it's 6, it'll evaluate it. If x equals 5, but y does not equal 6, it'll evaluate this one. And if neither is equal to 5 or 6, it'll evaluate the third condition. And let's see that one once again. And we have 9, 8, and 1. Okay, because we have the or on here. So it's saying, wait a minute. Wow. Right, because we have the or, because here it's saying, well, x doesn't equal 5, but y doesn't equal 6, so I can subtract here. So we're going to have to put the and in here to force it to the else. So this logic, I'm going to show you now what happens. Now we should get the else condition. And let's see that we do. And we do. So or is very weak in that you only have to meet one condition. So if we look at this logic, first one x has to be 5 and y has to be 6. The second one, y has to be 6 and x can be any other number. The third one, x has to be 5 and y can be any other number. And the last one, x and y have to be some other number besides 5 or 6. The and is very strong in that it binds you to the conditions, okay? The or gives you 1, and it's weak. So you notice when I had the or here, even though x did not equal 5, all right? Because what it did is it looks at what is x? And in the case here, let's take a look. 9 and 8. So first one here, x does not equal 5, and y does not equal 6. The second condition, yes, x does not equal 5, but y does not equal 6 either, okay? In the third one, x does not equal 5, but then, of course, y does not equal 6. And then the fourth one, that's the one that's evaluated. X does not equal 5 and y does not equal 6. But if we do an or here, we're going to spit out, and let's do the or for both of these just as a check. If I did an or for both of these, my question to you is, which would evaluate first? Well, all I have to find is a value that x does not equal 5. And I bet we're going to multiply them. So let's just see. And surely we do. And you can see what happens. I needed to meet just this criteria, and then I evaluate here. When I do the and, I need to evaluate both. Okay. And we saw what happened with the or before we subtracted. All right. So if then is very powerful in its own way. And you can use it not just for numbers, you can use it for conditions of, and we're going to see this when we do things like message boxes and other things. So you can use this to structure out logic, but you got to be careful. Now, can you use more than one operator? You can have an x does not equal 5, y equals 6, and z equals 3, or z equals 3. Once you start putting in a lot of operators, the logic becomes complicated. Let's just see what would happen. I'm just going to just type it. I'm not going to do anything or evaluate it. Z equals 7. So here, in this kind of logic, it's saying that if x equals 5 and y equals 6, that must be met. Or z equals 7. So either both have to be met or z equals 7, then you can add them. All right. Now, if I had or for all of them, only one condition would have to be met, right? This was an or here. So if x equals 5 or y equals 6 or z equals 7, if any of those conditions are there, I'm going to boom. And that may be too open for you. all right? But when you start getting into it, you're evaluating the end condition first, right? But here's the thing. Which one are you what are you actually evaluating? So is it x equals 5 and y equals 6 or z equals 7? The end condition is evaluated first. Okay, it's sort of like in math, the kind of PEMDAS, right? Parentheses, exponents, multiplication, division, addition, subtraction. So you would look at if x equals 5 and y equals 6 or x equals 7, then go. The or statement sort of weakens a lot of this here. Now, if we place it in a different spot, or z equals 7. If x equals 5 or z equals 7 and y equals 6. So first we look at the or. If one of those conditions are met, if x is 5 or z is 7, and we have to also have y equal to 6, so I could have 5, 6 for x, y, or 7, 6 for z, y. Then I can add them. So I'm always looking at conditions that will, the and is always going to be the, and let's show you it again, or z equals 9, doesn't matter what. So when you evaluate that, right, we're going to have here, let's see, dim z equals 9. All right, we're going to, I'm sorry, as dim z as integer, and we're going to go z equals 9. So we're going to see if this logic holds. I want to just try it. So we're going to have x equal to 5, and we're going to have z equal and y equals 6. So let's see what happens if I have a 5 and an 8. Let's see what we get. So we are going to add it. 5 and 8, of course, is 13. So we had here that x equals 5. All right, it found that one. And it says or z equals 9 and y equals, or z equals 9 and y equals 6. We know that z equals 9 and y did not equal 6. Let's have z equal to 3 and see what happens when we run this. We might just get it still adds it. So it's saying if x equals 5 or z equals 9 and y equals 6. So really what it's saying here is the or statement says, okay, z can equal 9 and x equals 5. That's the first thing it evaluates and it adds it. The or then says you could have z equal to 9 and y equal to 6. All right, let's put z equal to 9 back here. And let us try to make this one 2. Let's see what it gives us. All right, we're going to get 0. So what happens here is we know that z is 9, but x is 2, right? So x does not equal 5, and y does not equal 6 when we get to 0. So why didn't it evaluate here? We're going to try now putting y to 6 and see if it evaluates this one here. Let's see. I'm going to run that. And z is 9 and y is 6. So here we have x equal, oh, sorry, x is 6. Did I put x is 6? I wanted y is 6. Yeah, sorry. Let's put the 2 up there and put the 6 here. My goof. Got them in the wrong order. I should have labels there. Okay, so So when we have x equal to 2, well, obviously the first condition, x does not equal 5, but c does equal 9, and y does equal 6. Then we add them. So let's see what happens if we make z equal to 8. I should get 0. And I get 12. Why? Well, obviously the first condition is not going to meet, but the second one does, because x does not equal 5, but y equals 6, and we multiply them. Wow. Um, so what it's saying here is that, and I really should do the debug on z, but really actually it does debug z. It does. I'm sorry, it does. Well, so what happens here is, oh, I see. Hang on a second. Let's do it with a W. All right, and W. All right, let's evaluate this again on our conditions. Yeah, Z, I'm making a sum, so, and we're going to put W in here as well. All right, so let's make W 8, let's make X 5, and let's make this 8. Let's evaluate it. Yeah, okay, so we add them because we only define X equal to 5, or we can have Z equal 9 and W equals 6. Neither condition seems to work. So let's now put this as 2. Now we should get I believe we should get our 0 condition. Let's see, 2, 8. Yes, we do. We get the 0 condition because x is not 5 and y is not 6. Now what we're going to do here is we're going to make w equal to 6. And we're going to make y equal, I'm sorry, y. Shoot, this should be w, and this should be y. Getting confused here. Okay, so in the first one there, we need just to meet the x condition. 5 plus 8 is 13, so it doesn't matter what the other or condition is, it won't meet it. Doesn't need to, it gives us the 13, but if neither x or y is equal to 6, I'm going to get the 0. Now let's reverse it, so we have w as 9, it should be, here, and we're going to make y 6, but we're not going to make x. So we're going to make this 6, and now we're going to see if we get the second portion of that condition, and we do. So here we get w equal to 9, y equal to 6, right? And so 2 plus 6 equals 8. We're going to add up x and y. So what it's doing here is the OR is splitting up this condition here and these two here. So it's either x equals 5 or w equals 9 and y equals 6. All right, so in the logic, what you're doing and what you're saying here is I must meet either or condition. And so the or is what splits it up, not the and. The and keeps it together, and that makes sense. So now what we're going to do, let's see. Right, so let's just see. Now, notice here, x is not equal 5 and y equals 6, but w equals 8. In this case, I'm sorry, 9. In this case, 9, right? The w's over here. So it evaluated this one first. Now, what happens if we take this away and we make w equal to 7? Do the same evaluation. Well, we're not going to get this condition here. W is not 9. It's 7, so it's going to bounce to the second condition, or it should. And 2, 6, 12. Right, it's going to multiply, as you see here. And 7. And then what happens now if we go to the last condition here and we make x5 and y something other than that? Let's do 4. Or 3. All right, so, and this for obvious reasons, and we're going to get 5, 3. Oh, we're going to get the first condition. We're going to add it because x equals 5. Um, it's never going to bounce to the last condition because you have an or in there. If you had an and in there, let's put the and in there and see what happens. Now the and means I have to meet every single condition. X has to be 5, Y has to be 6, and W has to be 9. Let's get rid of these here. Let's see what happens. Let's run it. And I get a 0 because W does not equal 7, not 9, and it doesn't meet any of the other conditions down here, right? Because Y equals 6, and so I get 0. So now if I change Y to, I don't know, we'll go 10. There we go. Now we're going to say, hey, X is 5, Y is not 6. We get 5 minus 10, and then of course we get our 7 as our W, which didn't change anyway. So your takeaway here is when you start adding a lot of different operators and conditions, the logic gets complicated. What I want to remind you on the if-then statement is that you really have to be careful with it. You have to, an or immediately says the first condition or whatever the and or second condition or the components of the and condition are, and that was here. And many times you will override, and we saw this, this will override the second condition here. If I run this again, I'm going to add them. I'm going to get the first condition I had here. It's going to hit here because X has to be 5. That's all I need. You got to be careful. And we're going to get to the select statement in our next video. I think there's just too much time on each one. But your if-then statement is very important. It's something that is going to be useful for you, and you can evaluate it, as I said, with many different needs. One of them is going to be for message box. If the response is a yes, do something. If else, it's obviously a no. And the best way to use if then is in two conditions, a Boolean, a yes, no, a true, false kind of a thing, because it really is what it's utilized for. Now, a final statement on the if then. You can nest them. You can put an if then in your do something. You could put another set of if thens. But be careful, because if those conditions aren't met, it's not going to evaluate them. And many a time as a programmer, as a developer, you've got to make sure that those conditions are met and can be checked to meet. And if they don't meet, it's useless code. I want to emphasize that to you because it's important for you to know. So when we get back, we'll go to the select case, the next one in video 3. Again, I wish there was more time here, but going into all the possibilities, select case is the big brother or big sister, however you want to view it, of if then. And it's more specific. If then, typically you don't use the else if because unless you have a third possibility, right? So let's say for a Boolean, you could have yes, true, false, or unselected maybe, or something like that. Neither. It is possible when you have a checkbox. It could be checked, not checked, or inactive, or something like that. But the if-then statement is huge. It's big. And you need end ifs. And you got to be careful where those end ifs are. So if I take an if-then statement and I nest an if, I'm sorry, an if between this in this do something area here, I've got to have an if do something, if condition, then do something, else do something else, and if. All right, I've got to make sure. And the other thing about them too, and I'm just going to go here to close this out, is, and I want to show you this whenever you're writing these statements for the sake of making things nice and neat. Uh, uh, you see here, you want to have, whoops, sorry. You want to have it organized in such a way that I want to see this. All right, you see this here. You can read this. So I have if, my else if here, my other else if, and my else and my end if. And this is going to make coding very nice, very readable. Let's debug and compile and save it. So the if then is really important. And I hope this has been helpful for you. Please like and subscribe as always. I'm the Database Guy, wherever you are. Have a good evening, day, morning, night, whatever it is. And I will see you shortly. Take care.